1. Welcome to the part 4, 3 or 4, I forgot it, never mind. So before this, we look on the holding cost. Holding cost will be occur only for the cycle without having any shortage. If you look here, we only calculate from O to A and also B to C. Now what we're going to do, since in the total cost now we have a shortage cost, we will go still using the same method or techniques to find the shortest cost for the period of AB and also CD, or we can call per year. Okay, so if you look here, similarly shortage cost per year, it means that we need to understand what is the shortage, cost per cycle times with cycle per year. We are still using the same method like how we do just now to calculate the shortage cost. So if you look here, shortage cost also means that shortage that occur during time interval. Which time interval? In this, if you look on the first cycle, time interval of A and B. So it means that we also can calculate that the average shortage level. If you still remember what the average level is, the Q over 2, we go in the same formula. It means that it should be the half of maximum shortage. Should be half of the maximum shortage, or it means also our Q minus M over 2. If you look here, our maximum shortage is Q minus M. We're using the same formula for average level of the shortage, Q minus M over 2. Okay, next we know that AB is the time interval. We know that AB is the time interval of Q minus M over demanded quantity. They still demand at this time. Okay, so that's why I put the QM minus D, and now we can calculate our shortage. I will just bring here. We can calculate our shortage cost per cycle as half of the average shortage. It means half Q minus M and times with our time interval of the demanded quantity. It means Q minus M over D. And when we short out plus, we need to include the shortage because this is the under shortage. Okay, under shortage. So what we get is Q minus M square S over 2D. So because since these are on shortage, we add an additional symbols of shortage. So this is for cycle. Since we still using similarly D over Q cycles per year, so we can calculate our shortage cost per year will be our shortest cost per cycle. It means that our Q minus M square over 2D times with S, or times with S, and we just times with D over Q, so that we will have Q minus M square S over 2Q, because we can put on this one and put on this one. So we have Q minus M square per 2Q. And finally, for cost of order, of order, we just use our, we call as C naught, is according to KD over Q. We did not involve on shortage on the cost of the order. Since we are going to use this formula, our holding cost, our average shortage cost, and our shortage cost per site per year, and also cost of order, then we can form a new total cost, which is our new total cost under Q and M. Q means the quantity ordered during shortage, and M is the maximum average inventory. We can get KD over Q plus our shortage cost Q minus M squared over 2Q, and finally our holding cost. If you still remember, what do you get? Our holding cost M square over M square H over 2D. So we are going to use this formula and differentiate partially to form a new EOQ, new ordered quantity and new maximum inventory, where I will show you now. So what going to happen is we will differentiate respectively DTC over DQ of Q and M. No star yet. Another one, this is according to 0, and the next is we also going to DTC over DM equals to 0. Q and M equals to 0, where for this one we can get our new so what we're going to get is when we make DTC over DQ and DTC over DM equals to 0, we can differentiate. You can do yourself. So we can get actually 2KD H plus S over HS, or we also can make it as, if you look here, 2KD over H is actually EOQ, right? Our quantity, still remember our quantity optimal is square root 2KD over H. So we can take it out, that one. So we just put EOQ, or we just put EOQ. In the bracket, we have another thing called H plus S over S, and power of 1 over 2, or square root. Same goes for the M, where we will have finally our 2KDS over H plus S square root, where if you look, take it out again, we can get EOQ of S over S plus H half. And now we already get a new order quantity. When we have shortage, this formula can only apply when we have shortage, and this is the maximum average inventory when we have shortage. How many we should backlog? That's why we need to learn this one first before we understand about backlogging. And finally, we can also find the maximum shortage, or I'll put capital S as Q minus M, where we know when we incorporate both of the equation, we will get 2KD R minus D H over S R H plus S power of 1 over 2. So we can use this formula. So this is just a theoretical part how the formula is derived. in your assignment on test, you need to understand the concept how I'm explaining now, so that you can start to do the exercise that I already prepared your slides and already going to send in the Microsoft Teams tonight. So what you should do is you should understand the formula and try to do. And do remember, because there is a few books that I'm taking, so some of the books or slides will have the carrying capacity. It's still the same thing as I already teach previously. Thank you.